I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In case you want to learn from me, you can always send an email on the address given. Here is an excellent question from my student Amy. You can also post your questions, send me an email, and I will provide you with a simple and required solution. The question here is based on Venn diagrams and probability. We are actually talking about conditional probability. The question is A, B, and C are three events with probability of A equals to 0.25, probability of B equals to 0.4, probability of C equals to 0.45, and probability of intersection of A, B, and C is 0.1. Given that A and B are independent, B and C are independent, and A intersection complement of B intersection C is a null set. So these conditions are given to us. You need to draw a Venn diagram to illustrate the probabilities. Find probability of not A intersection with not B union C. Find the probability of A union B, not C. State with reason whether events complement of A and C are independent. So that's a very beautiful question. It actually gives you the whole concept of the unit, and that is why it is appearing as our featured question on statistics and probabilities. I hope many of you will benefit from this. You can also pause the video at this stage, attempt, and then look into my solution. Now, a very difficult thing to understand in this is the condition given to us. Given that A and B are independent, that is clear, and B and C are independent, that is absolutely clear. However, the last condition here, which is A intersection complement of B intersection C, is a null set. Now, this is a very confusing statement. I shouldn't say confusing, but it is a very difficult statement to understand by most of the students. So, do you understand this? What it really means? So, we'll actually start from here and then look into the solution, which otherwise is not very difficult. So, let's look into how do we solve such a question. Now, first step is when you are given three events, in that case, you should draw three circles as shown here intersecting one another. So that is how we'll actually begin with the Venn diagram. Now, as I was saying, it is kind of important to understand the statement which is A intersection not B intersection C equals to 5. If I explain you this, I'm sure you will be able to answer this question without further looking into my solution. My idea is when a student comes to me, I try to understand what was the real difficulty. And if I'm able to solve that, then the students on their own can provide solutions. So that's what I'm going to do here. So let's look into this, which is A intersection not B intersection C. Let me rewrite this. So A intersection not B intersection C. So let us see what is A intersection C equals to, right? So A intersection C, let me shade that portion. So A and C intersect in this particular area, correct? So that is the portion which is A intersection C. Perfect. So now we got A intersection C, which I have shaded. Now what I want to do is to understand what is A intersection C intersection not B. Do you see that how I'm getting to this? Not B. Not B means that I have to take something which is not B, not included in B, right? So outside B, that intersection. So we are talking about this portion. You get this idea? So this is what is A intersection C, and it intersects with something which is outside of B. You see that? That's the region. And now we are saying that this is a null set. That means here there is nothing common. It is zero. Do you see that? So that is the starting point for us to understand what was very difficult to figure out. Now I think you can easily solve this question. Am I right? Perfect. So you can now pause the video and go further. Now let us see our step 2. How do we solve a general question based on three conditions, three events? Well, let's get back to the question now. It says A, B, and C are three events with probability of A as 0.25, probability of B equals to zero point 0.4, probability of C equals to 0.45, and probability of intersection of ABC is 0.1. So we always begin with inside out. So we'll begin with inside out. That is the common intersection of all the three events. Is that clear to you? Okay, so now we look into what is the probability of A intersection B intersection C. That is given to us as 0.1, and this is the portion right there, correct? So we know that A intersection B intersection C is 0.1. Now from here, we can now get to the other common intersections between the events. So let's get back to the conditions given to us, and that is, given that A and B are independent. Now, what does this statement mean? A and B are independent. Let me use a different ink. So now we look into, given that A and B are independent. Now, when I say A and B are independent, it really means that the probability of A intersection B is basically equal to probability of A times probability of B. You get the idea. That is the meaning of independent events. So if the events are independent, in that case, the probability of A and B is same as probability of B and A, right? They are independent, and it is same as product of probability of A and B, correct? So now to find this, we will find by given probabilities of A and B, probability of A is given to us as 0.25, and we're going to multiply this with the probability of B, which is given to us as 0.4, right? So that is 100, which gives us 0.10, correct? So we get this intersection of A and B as 0.10. Well, the common between the two is already 0.10. That means nothing goes here, right? Because that is already there. So that is another way of looking into it. We already know that 0.10 is common between A and B. So nothing goes here, correct? So it is blank, correct? So now let's move forward and see how do we find the intersection of B and C. So when you say probability of intersection of B and C, in that case, what are you going to do? You are going to multiply these two probabilities, correct, for B and C, and then take away from point 1. Perfect. So let's move on to a fresh page, correct? Okay, so let's move on to the fresh page. What we have found so far is that the intersection is given to us as 0.1, correct? And these two are blank for us. Now, we'll look into the probability of intersection of B with C. Since these are also independent events, B and C are independent events, we can multiply the individual probabilities to get the result. Just as we did for probability of A and B, correct? So what do we get? So we get here probability of B is given to us as 0.4 times probability of C as 0.45. Just multiply and get the result. Zero point 0.4 times 0.45 gives us 0.18. So the combined probability of B and C, the intersection, is 0.18. Since 0.1 is already there, then what comes here? Well, at this place, it is 0.18 minus zero point 0.1, correct? So that gives us 0.08. Is that clear to us? So this portion is 0.08. Combining the two, we get 0.18. Is that clear to you? Perfect. So we got this probability. Now we can move forward. We know that the probability of A is 0.25. So we know that the probability of A is equal to 0.25. Now from there, what will come in this place? Well, clearly, zero point 0.1 is already given to us. So here we are going to get 0.25 minus zero point 0.1, right? So let's do 0.25 minus 0.1 and we get our result as 0.15. Is that clear to you? Correct? Now, similarly, we can find what comes here. So that is from the probability of B. Probability of B is given to us as 0.4, and from there we know that the intersections are 0.1 and 0.08. So from 0.4 we'll take away 0.1, that is 0.3, and then we'll take away 0.08. So let's do this. So 0.4, take away 0.1, take away 0.08. What do you get? Well, we get 0.22. So here we get 0.22. Clear? Now let's look into what comes here. So probability of C is basically given to us as 0.45, and that gives you that for C we already have 0.1 and 0.08. So from 0.45 we'll take away 0.1 and 0.08. So that gives you what? So it is 0.45 minus zero point 0.1 minus zero point 0.08, and that is 0.27. Clear? So I hope this solution is absolutely clear. Let me summarize this for the benefit of our viewers. Okay, so in this type of a question, what can we do? Well, it's very important to understand these statements given to us. When we say A and B are independent, it means the probability of A intersection B is the product of probabilities of A and B. Independent B and C means that the probability of intersection of B and C is the product of probability of B and C. And when we say that A intersection not B intersection C is null set, then we are looking into this particular portion. You get the idea. So this is null set. You get the idea. Once you understand that, then you begin your problem. Well, this question could have been solved even without getting into this condition, since the intersection of each probabilities will give you that result. Okay. But anyway, it is important to understand the concept. So begin with inside out. So first step, write point one, and then individually figure out what is the intersection of A and B. So we are given this particular condition and find what should come here. Then move on to intersection of B and C, that is this region. And you'll get a value which came to 0.18. Point 0.1 was already there, so we wrote 0.08 here. Now, once you work out all the intersections as shown here, in that case, you can move outside. Look into probability of A. Whatever is given, take away that, and remaining will give you the probability which is only A. And then probability of only B and only C can be calculated as we discussed. Now, once you do all this, then one thing is left, and that is what? The total probability is 1. You get the idea, right? So probability is basically the sum of probabilities should have been 1, right? So we are looking for adding all this, correct? What comes outside? This is very, very important, correct? So now, when we talking about the set as such, if we sum all these values, then we do not get 1. Correct? You have to do it. So let me write down a note here, which sometimes is missed. Okay. So what comes outside is what is the probability of not all these, correct? So that is what we are looking into, right? So that is 1 minus, you have to add all of them. So write them in order, in any order you want. 0.1 and then 0.08 and then 0.22 and then 0.27. And when you take it, what do you get? So use your calculator, find this value. It comes to 0.18. And that is the probability of neither A, B, or C. Perfect. So it is complement of, if I say A union B, union C, complement. That is outside these circles, and this is equal to 0.18. You get the idea, right? So now we have the complete solution, as you can see, right? So that will really give you full marks for question number A. And now we have drawn the Venn diagram. Is that clear to you? Perfect. Let's move on and see how do we answer part B. Now for each part, we already have the values which I have shown here in the Venn diagram. Now we need to find probability of not A intersection not B union C. Now what does that mean? This is what we need to figure out, correct? So how do we do that? So let's see which part of the Venn diagram are we really looking into, right? So here, let's start with what is not B union C, right? So not B union C is, union C means everything inside, correct? And not B means outside B, correct? So I've shaded the portion as you can see, correct? And now we want to do intersection with not A. So intersection with not A really means what? Not A means outside A, right? So not A. You see that. So that is the result. And now clearly, you can see there are some values which you cannot include, right? And therefore, we can now combine all the answers, correct? So, so we have the solution which is equal to what? So in the shaded region, you cannot include 0.15 which is within A, not A, right? So which is within A, and zero point 0.1 cannot be included, correct? Not B. We cannot also include 0.22, right? So what we can do is 1 minus 0.15, take away 0.1, take away 0.22. Is that clear to you, right? So these are the three things which are not included, and that gives you the answer. So let's do it. So it is 1 minus 0.15 minus zero point 0.1 minus 0.22, and that gives you 0.53. Do you see how from the Venn diagram you can visualize and find the solution? Is that clear to you? Correct? Now let's move on and see how do we do part C, which is a similar condition. It is probability of A union B intersection C. Correct? So we have to intersect something common with C, but union of B, A and B, right? So A union B means we are talking about these two events, right? And what is common between A union B with C? So you can see with C, this portion is common. So A union B, everything but intersection with C. So we have 0.1 and 0.08. So that is equal to 0.1 plus 0.08, and we get our answer as 0.18. Is that clear to you? So once you make your Venn diagrams, things are much simpler. Now let's move on to the last condition, which is state with reason whether the events complement of A and C are independent, right? So for independent events, what do? We need to find the probability of not A. Probability of not A is 1 minus probability of A, and which is 1 minus 0.25, or you can say 0.75. And probability of C is already given to us, right? So we know probability of C is 0.45. Now from here, what is the probability of not A intersection C? This is what we need to figure out. Well, not A intersection C is given to us from the Venn diagram, right? So when we say not A intersection C, we are looking into what? We are looking into these portions, correct? Not A intersection C. So this portion here is equal to 0.08 plus 0.27, right? And 0.35, correct? So we get this probability from the Venn diagram. Now, let us find what is the probability of what is probability of not A times probability of C. If that is equal to 0.35, then the events are independent, right? So probability of not A is 0.75. We are going to multiply this with probability of C, which is 0.45. And we get what? 0.75 times 0.45 is equal to 0.3375. Now they are not equal, right? So you see that they are not equal. Since they are not equal, the events are not independent. You get the idea, right? So, so we know that probability of A intersection, complement of A intersection C is not equal to the probability of not A times probability, and I should say C, and therefore we know they are not independent, right? Is that clear to you? So that is how we are going to answer this particular question. So I hope all the steps are absolutely clear. So once again, coming back to this question, I hope you have learned how do we solve probability related questions using the Venn diagrams. Now this particular question is excellent. Let me thank Amy for sharing this question with us so that we could actually get overall view of what exactly it means to solve a question which is related to probability and which involves the Venn diagrams. Thanks for your time and all the best.